Welcome to SV Union High School and Junior College. Let's discuss about the important component, that is transformer. What is transformer? Transformer is a static device. It transfers electrical energy from one part of the electrical or electronic circuit to the other part of the electronic circuit without changing the frequency. It works on the Michael Faraday's law of electromagnetic mutual induction. Figure shows the use of transformer. As we know, we are getting the electricity from the MSCB office, that there is a generation station which is generating the electricity. Then this electricity is transmitted to the customer by using the transmission lines. This energy is having large voltages, though the customer requirement is less. That's why there is a step down transformer is used, which will step down the voltages, and that voltages are supplied to the customer as per the requirement. There are different types of customers like sub-transmission customers, primary customers, and the secondary customers. The need of electricity requirement of these all customers is different. Like sub-transmission customers are required 26 kilovolt, primary customers require 13 kilovolt. So as per the requirement, the electricity generated by the generation station is reduced. It is stepped down by using the step down transformer, and it is supplied to the customer as per their requirement. Let's discuss the history of transformer. The first transformer was developed by Otto Blathy, Micah Derry, Karli Zabronsky in 1885. Further, in 1885, William Stanley makes the transformer more practical due to some design changes and developed three-phase transformer. A design of William Stanley was first commercially used in USA in 1886. Figure shows the construction of transformer. As shown in figure, there are two types of coils in a transformer. First coil is known as primary coil, and the second coil is known as secondary coil. The voltage across the primary coil is denoted by Vp, and the voltage across secondary coil is denoted by Vs. As we are supplying the AC voltage to this transformer, by using these two windings, the voltages are transferred from one winding to another winding. There is no physical connection in between these two windings. Voltages are transferred from one winding to another winding without any physical connection. What is the working principle of transformer? Physical basis of transformer is mutual induction between two circuits linked by a common magnetic flux. The transformer works on mutual induction. If one coil is connected to a source of alternating voltage and alternating flux is set up in the laminated core, most of which is linked with the other coil, in which it produces mutually induced EMF. Let's discuss about transformer. A transformer is a static device which is used to step up or step down voltages at a constant frequency. It consists of two coils that are electrically isolated but magnetically linked. The primary coil is connected to the power source and the secondary coil is connected to the load. The voltages are step up or step down by using the transformer. Voltage is step up or step down proportional to the turns ratio. The turns ratio is the ratio between the number of turns on the secondary winding to the numbers of turns on primary winding. The numbers of turns in secondary winding is denoted by Ns and the number of turns in primary winding is denoted by Np. Let's see how to find the turns ratio. The turns ratio is given by the formula turns ratio is equal to number of windings in secondary to the number of windings in primary is equal to voltages in secondary to the voltages in primary. We can also write this formula as Vs upon Vp is equal to Ns upon Np, where Vs is secondary voltage, Vp is primary voltage, Ns is number of turns in secondary and Np is number of turns in primary. Transformer classification. Transformers are classified according to construction, application and on cooling. A transformer is a static device. The word transformer comes from the word transform. Transformer is not an energy conversion device, but it is device that changes electrical power at one voltage level into electrical power at another voltage level through the action of magnetic field, but with a proportional increase or decrease in the current rating without a change in frequency. It can be either to step up or step down. Let's see the need of transformer. In most cases, appliances are manufactured to work under some specific voltages. Transformers are used to adjust the voltage to a proper level. The transformer are the basic component for the transmission of electricity. Transformers are used to increase the voltage at the power generating station and used to decrease the voltage for household purpose. By increasing the voltage, the loss of electricity in the transmission purpose is minimized. The generating electricity at power station is known as step up and the decrease the voltage for the household application it is known as step down. Applications of transformer. Transformer transmitting electrical energy over a long distance through wires. Transformer with several secondary are used in television and radio receivers where several different voltages are required. Transformers are used as a voltage regulator. Transformers also used everywhere in day-to-day life. Basics of windings of transformer. As we know, there are two types of windings in a transformer: primary winding and secondary winding, or it is known as primary coil and the secondary coil. The first winding is known as primary winding, the second winding is known as secondary winding. There are two types of transformers are there. As we already discussed that transformers are used to step up and step down the voltages. So, what is a step up transformer? The number of turns in a primary winding are less than the number of turns in a secondary winding. Means if the number of turns in a secondary winding are greater than the number of turns in a primary winding, then the transformer works as a step up transformer. Step down transformer. The number of turns in a primary winding are more than the number of turns in a secondary winding, then the transformer works as a step down transformer. Isolation transformer. The number of windings on primary side are equal to the number of windings on the secondary side, then the transformer acts as a isolation transformer. Means on the basis of number of windings, the transformer works as a primary step up transformer or step down transformer. So this is all about transformer. Thank you.